Welcome. This question says a pipe's height is 2 meters above the table. The water pressure at the entrance is 90 Pascal. The water speed at the entrance is 8 meters per second. So we're given a whole bunch of information about this entrance. The water density is 6 kilograms per cubic meter, so we know the density of the fluid. And the pipe's exit is 4 meters above the table. And the water pressure at the exit is 50 Pascal, and show that the speed of the water would be 6.1 meters per second. Okay, so this is Bernoulli's equation. Let's do ourselves a nice diagram. So we know that at the entrance we have a velocity of 8 meters per second. I know my pressure is 90 Pascal, and I know my height is 2 meters. Let's draw this across and then just have this snaking up like that. I'm not given any information about the cross-sectional area of the pipe. I know that at the exit I have 50 Pascal. I'd like to find this velocity at the exit, we'll call it V2, and I know that this is 4 meters above the table. So the pipe is higher at the exit than it is at the entrance. And I know that my density of my fluid is 6 kilograms per cubic meter. So there's my visualization. I'm given a whole bunch of information. I want to find this one piece of information. What is the exit velocity? And hopefully this will prompt in your mind Bernoulli's equation. And Bernoulli's equation basically says that the pressure at one point in the pipe plus 1/2 times the density of the fluid times the velocity of the fluid squared, a half rho v squared, plus rho times g times the height of the pipe at the beginning. That's a constant, so all of that equals, pick another point, pick the exit. The pressure at the exit plus 1/2 rho v squared, where v is at the exit, plus rho gh, where h is at the exit. So the rest is actually math. We say, well, we had 90 Pascal plus 1/2 times 6 times 8 squared plus 6 times 10 times 2 is equal to, well, it's going to be 50 plus 1/2 times 6 times v squared, that's what I want, plus 6 times 10 times 4. So 90 plus 8 8s are 64, 3 times 64 would be 180 plus 12, 192, plus 120 is equal to 50 plus 3v squared plus 240. So we can rearrange and say, well, 3v squared is going to equal, that's going to be 120, 210, 310, 402, 402 minus This would be 240 and 50 makes 290, which equals 112. So v squared is equal to 112 over 3. So v is equal to the square root of 112 over 3, which equals, let me get my calculator, and I go second square root. I'm going to go 112 divided by 3, close my bracket, and I'm going to get 6.1. So this is 6.1 meters per second. And there we have it. It looks, it's an involved equation. There's a bit of memorization there. But basically, you know, one equation, one unknown. I can only miss out one thing. So I could not tell you the final pressure and ask for it, or I could not tell you the final velocity and ask you for it, or I could not tell you the final height and ask for it, or I could not tell you the density of the fluid and ask for it. I can play with it. I can throw in non-standard units. I suppose I could do ratios where I could say to you, oh yeah, this height is 3 times higher and all that. But basically it's one equation, one unknown, so know the relationship, know what all the symbols stand for, and then just work through it. There we have it.